So as you've heard, my name is Ben Davidson. I run the Suspicious Observers YouTube channel. It is under the company Space Weather News, and it is the most watched solar and earthquake news show on the internet. When you have more than 250,000 people who are interested in the same types of material, the same topics, things like that, you really end up getting a good feel via your interactions and your communications with those people, exactly what their level of interest and what their level of awareness of those topics actually is. And so, try to imagine if anyone here has wrapped their head around the corpus of the electric universe realm. Take somebody like Eugene Bagashoff. 10 years, he's going to be worth 10 of me. Today, the layman might not fully understand what he's saying. Same could go for my work as well. And so, taking the idea that this conference is about elegant simplicity, and taking the idea that many of the people who are really interested in this, the people who are going to carry this interest forward and share it with other people, maybe they should get a nice little corpus of understanding as well about exactly what electricity is and what it looks like. Because frankly, even people who I interact with who are really into this stuff, a lot of them do not know some of the basics. What does electricity look like in the atmosphere? What does it look like in a vacuum? What about AC versus DC? With all of the complex math and physics that is coming out of this community and this movement, what are some of the most elegantly simple paths forward that are likely to offer success for our community? Those two things are what I'm going to try to deliver to you today. A little bit of basics about what some of these things actually look like, and then trying to begin a narrative about the path forward. And it starts with a little bit of that education, which is the first word you got right there underneath the title. So, we will come to this, and we're going to start with the video, and hopefully the audio is muted on this so you can hear me. Essentially, what you're going to be looking at is the same thing at different speeds. And what you're looking at here is you see these plasma flows or plasma currents, however you want to see it. And then other times in the video, you see what is clearly lightning. There is no difference in the current being applied, the amount of voltage, the amperage, or anything other than the ambient environment inside of this chamber. When there is lightning bolts, that is when this chamber is full of air. When you have the plasma streams like you see here, we have done nothing but turn on the vacuum and create a vacuumous environment. It is the same electricity changing when the environmental conditions change. This is the difference between electricity in the atmosphere, which you see as the lightning, and then as we pull the air out of the chamber, you can see the lightning disappears, and we start to go towards this more smooth plasma current. This is a very, very basic idea, and literally the difference in the input between these two things you're seeing here is nil. Nothing. There is no difference. But take a look at how the environmental conditions actually change what this thing looks like. Let's go on to the next one. Now, this is alternating current in the vacuum. You can just pretty much see how we have this current coming both ways. You have this discharge from both sides. It's really quite simple, and it's exactly what you'd expect from alternating current going both ways. Well, when we switch it to DC, do you notice the difference? One side is vastly, vastly more active than the other. The anode is the one where it's got the arm pulling away from it. Now, what we've done here is we've gone back to AC, and we've turned it up, and you can see how that one was building from both sides, where when we have plasma glow, it really reaches from just one side in direct current. This is important, especially as we're looking for some of these big structures in space. DC in the atmosphere, notice how one side is brighter than the other. Can you see how one side is brighter than the other? Well, watch what happens when we switch to alternating current. We will no longer see one side carrying the breadth of the energy, but we see it shifting back and forth. Now, is this groundbreaking? Is this going to help us publish any new papers or discover anything about the universe? Probably not. However, when you start to look at some of the large-scale structures in the universe that are almost ubiquitously explained by the mainstream through gravity, you begin to get a different idea for how some of these strange lines appear. And certainly they're more columnar. They're tubes, not actually lines. The linear word is just describing what they look like from afar. But you start to look at galaxies and stars forming on a string. You see these connections between things. And the only explanation we're given is gravity. I'm just going to go through a couple of images here of interesting things you can see out in space that if you didn't know what electricity looks like in the atmosphere versus a vacuum, AC versus DC, how would you even attempt to interpret what you're seeing in some of these images? Not to say you're going to automatically have the right answer, but you have more tools in your toolbox. This is one of the best examples that you can see right here. This is a cosmic jet coming out of what the mainstream describes as a black hole. I will love it, by the way, when EU gets a better name for those things. But the segmentations in the cosmic jet are equidistant apart. That is not something that is the result of gravity. Not even close. This, to me, looks like the peaks of a waveform or something to that effect. Hopefully your mind can start to get into that realm rather than gravity. Many of you know what this image is. This is what they call the cosmic web. And of course, the mainstream describes this stuff as dark matter and dark energy. And I'm going to talk a little bit about that. But regardless of the fact that we're all pretty sure they don't have exactly right what they're looking at, what we're looking at shows lines, or those linear tubes, if you want to call it that. Is that gravity somehow pulling all those things into lines like that? Because that's what the mainstream says, that it's gravity that does these things over large time scales and large spaces in the cosmos. Maybe there's another explanation for this. This one's one of my favorite. You can see all the little dots with a line going through them. Each one of those is allegedly one of those cosmic jets. And you can see that they are surprisingly aligned along these lines. Not necessarily in relation to one another on the other side of the image, but take a look along the individual plasma lines, the glowing lines there. And what is the explanation that the mainstream gave for this amazing cosmic coincidence? There must be some primordial gravitational force that caused them all to form and start spinning and eject their cosmic jets in the same way. That's very, very difficult for an electric universe proponent to get behind. This is one of my favorite images because this is from the same scientist group, except they were looking at a different part of the sky. Up in the corner, within that green triangle, you can see cosmic jets that they've all determined are going the same way. All the blue circles are cosmic jets that are in the same part of the sky that are going the same way. And all of those red rectangular things, those are very much in the foreground. So that green triangle and the blue circles, the ovals, those are actually a bit further back in this image. But the most foreground stars and cosmic jets are actually in those red rectangles. And you can see they're all pointing in the same direction. Again, the explanation given to the world, some primordial gravitational orientation set all these things up to just be this way. There's probably a much better electrical explanation for it. And by the way, something that is not mentioned at all, over on the left side of that image, can you see the really, really bright object with all the concentric rings of red around it? Not a single word has ever been given on what the heck that is. So, as you go forward into the electric universe realm, and as you try to make sense of a lot of these things, especially if you are a novice or you are just getting into these things, think about some of the simple things you can see, some of the simple things that allows you to determine, hey, this is electricity, but what are the conditions around it? Some of the things that Billy Yelverton does in our electricity and plasma lab are absolutely mind-bending. But anyway, so this is what electricity looks like, and you don't have to change very much about the current. In that second video we saw where there was AC in the atmosphere, DC in space, AC in space, and you saw things going. We changed the current 0 times. It is the same electricity going through every single one of those systems. But if you don't know how the environmental conditions will change what you're seeing, it's very difficult to comprehend or wrap your head around what it is you're trying to observe in the natural world. So let's move on really now to what are some of the pathways forward? The pathways that are not as complex as some of the most complex things in our community. Where are we likely to find the most success easily that will open the door to everything else that we are trying to communicate to the world as a movement and as a community? Well, one of those, and you'll all forgive me for starting here, is with the examination of earthquakes in the sun. Last year, I talked about this a little bit. I did a study with Dr. Kongpop Uyen and with the statistics department from The Ohio State University, and covered the data on the sun's magnetic fields and how they interacted with the Earth. And we went up through 2014, or to the start of 2014, and that's what we talked about last year, and how we had a very, very strong correlation that was presented by these statisticians in confirmation of what we thought we were seeing. And at that time, we were going to be looking to publish this, get it peer-reviewed, and continue on into the future. Well, since the last conference, we did get this peer-reviewed. We had another statistics group look at it, pretty much confirmed everything, and since the publication, things have looked even better than they did before the publication. Let's just go into a little bit of this. On the one side of the chart there, you can see the earthquakes that occurred up through 2013, and we'll talk about the right side of this image in a moment. But those curving lines that, the blue, the red, and the yellow, these are the curves for the magnetic power of the sun. The blue is what we recognize on the north, and the red is what we recognize on the south. I've added the yellow line where we combine those two to get a total magnetic power offered by the sun. Now that center line going through the middle, which is a bit more purple than the other horizontal lines, which are gray, that's the zero baseline. Because we're talking about magnetism, we can go positive or negative, and I've chosen to make positive in the up direction, negative in the down direction, which is fairly standard when you do things like this. But approximately once per year, and what you see in these little waveforms here on these curves, each wave up and down is approximately 1 year. So every year, for a couple of days, we witness the sun's magnetic fields peaking in strength. As they're going to do, it's going to be the highest amount of force they're going to have all year. And then approximately every 10 or 11 years, we see a number of magnetic reversals as sunspot maximum occurs. Let's start with the left side of this chart. On the left, we have a magnetic peak. The sun peaked in magnetic power, and an 8.8 struck Chile within a few days. The next time it happened was March 9th, 2011, and 2 days later, the Japan disaster. Many of you know the only instance of 2 8-pointers occurring on one day was April 11th, 2012, just a handful of days after the next peak. And the peak the next year in 2013 saw an 8.0 hit the Solomon Islands. Now, at this point, we're done with the nice up and down peaks that we see. We're entering the reversal period. Now, while the total magnetic fields in yellow and while the northern magnetic fields in blue seem to cross the baseline and have multiple reversals, the southern magnetic fields of our star had only one reversal this cycle, just one, and it occurred the day a magnitude 8.3 struck the Kamchatka Peninsula of Russia. Now, it's a little bit harder to see on the right side of the graph, so let's go ahead and break that out a little bit. This is 2014, 2015, and 2016 thus far. So, the periods we look at are not only those peaks in the magnetism, and not only the reversals, but the periods where we enter the transition. So, when we enter the transition from the nice waves to the reversals, it is a reversal that signifies this. But the ending of that period rarely occurs with a reversal, because this is when the curves stop interacting and then they break. You can see that over on the left side. During the reversal periods, these lines will cross each other many times, but at some point they get sick of each other and they break away for their respective polarities of the new cycle. Within 3 days of them breaking apart and going to their new sides of the cycle, that was when we had the 8.2 hit Chile in early April of 2014. That's the far left one. The very first spike of magnetism was one down in the negative. That's the second line you see right there. That was a 7.9 that struck Alaska. The next lines you see are from 2015, and as you can see, these things are really just pointing at the peaks up and the peaks down. Those are 6 of the 8 largest earthquakes in 2015. And of course, not every single earthquake matches this, and not every single peak gets a major earthquake, but we only have one of these major earthquakes about once a year. And when you only have these peaks in magnetism or these other significant events once or twice a year, having all these earthquakes happen within 2 days, 4 days, at most a week and a half away from these periods, where otherwise these events are separated by hundreds of days to years. That is a spatiotemporal link that cannot be ignored. By the way, that arrow down on the bottom right, that is the first great earthquake of 2016. That was a 7.8 that struck off the coast of Sumatra on March 2nd of this year. Now, these presentations for this conference were set about a month ago, fairly standard when you have conferences like this. But in that last month, we have had a fair bit of data come out. Not only do we know that that downward curve of the yellow and the red that you see there has started to go back up, we know that that spike down there where that arrow is in the bottom right was indeed the low point for the total magnetic strength of the sun. And low point, I mean most negative. In fact, the sun's total magnetic field had not presented Earth with this negative of a magnetic force in more than 15 years. And on that day, 7.8 struck Sumatra. Now, on the very bottom right corner, you can see a tiny little hitch in the red line. We now have enough data to know that that was actually the most negative peak of the red southern fields. And on that day exactly was the magnitude 7.8 that killed hundreds of people in Ecuador. These things are blatantly obvious. If you can see the peaks, if you can see where one line crosses another line, you can do this. There are a number of middle school children who we have shown this to, and they can pick it out pretty clearly. In fact, we usually show them something like this first, without the earthquakes annotated on them. And we say, what are we pointing at here? Almost all of them say, oh, your lines, they're pointing at the strongest magnetism, or at that point where it crosses the middle. Well, that is exactly what the lines are pointing at, yes, but the lines don't point at every peak and every reversal. The lines are actually showing when the big earthquakes occur. So essentially what we have here is the biggest earthquakes on the planet, more than 85% of them now that we have up through the half of 2016, More than 85% of the largest earthquakes on the planet will happen within about a week of these peaks in magnetism. Now, if you want to learn more about this or read some of the papers, we have now published 4 works on this, and we'll continue to publish all the things into the future on this same website, spaceweathernews.com/SPF. And those who watch our daily news and our stuff on YouTube know that we've issued a bit of a challenge. 7 days ago, we issued a challenge to the USGS, specifically to one of their big guys, Jeffrey Love, who has spent pretty much the last 10 years publishing papers saying that the sun doesn't cause earthquakes, the sun can't cause climate change, kind of the things that make people like me cringe. And so if you can see how simple this is, that it's not just lines that are pointing at the peaks of magnetism. I'm not trying to point out peaks in magnetism and reversals. Those lines are actually the biggest earthquakes too. It's that simple. And when it is this simple, hopefully, even the United States government can't ignore it, and they'll have to use it to try to start warning people, saving lives, things like that. We're going to come back to earthquake forecasting in just a bit, but I would like to give you a quick little idea about just what the mainstream knows, and maybe what they have put out, but not really wrapped their own heads around. You know, when you look at the sun, you see Fibonacci spirals and other things like this everywhere. Almost every time there is an active region or a large solar prominence near the edge of a coronal hole or sector boundary, you will see something like this. Oh, and by the way, I didn't draw that. This is from NOAA, NOAA.gov. This is our government that drew that. And just as I didn't draw that one, I didn't draw this one either. NASA drew this one. So it's not as though there is a lack of recognition. It's not as though there is an ignorance. There is a lack of communication. There is a lack of focus on some of these things. You can find this stuff if you dig. They know it. They don't know what to do with it. They don't know how to communicate it. And most of the people who are in that position would essentially be saying, I've been wrong about everything I've been saying for the last 25 or 30 years. So the chances of them doing that is not exactly good. It's up to the community to calmly and clearly communicate some of these things. When you show somebody that picture, or the picture of the Fibonacci spiral on the sun, when you show somebody 8 different things about sunspots, and you can come to a hurricane and say, oh, there's all 8 things in the hurricane, in the clouds. These are things that can't be ignored. When you show that all of the earthquakes are happening at either the strongest magnetic periods or when they reverse positive to negative, this isn't like interpreting facts. This is plain and simple. It is elegantly simple, even. Just like some of these images are. You can see the spiral when you look at a low-pressure system with a long convergence tail coming off of it. When you look at the sunspots right next to the sector boundary of a coronal hole, you can see the Fibonacci curve. This isn't like trying to put together complex equations or high-level physics, and even the facts that you're putting in there are disputed, let alone the interpretation of those facts. This is as plain and clear and simple of a path forward for success as I could possibly imagine. So, words that make electric universe proponents go, ugh. But if you would indulge me for just a moment, what do we hear about dark matter and dark energy? Well, we know that this encompasses most of the universe, they say. In fact, when you look at things like the galactic rotation problem, galaxies should spin apart and have their arms actually bend back all the way around, but they don't. They hold form very well. Their explanation is that dark matter and dark energy are actually holding these things together. And we can't really detect it very well or interact with it or study it very well. There's still a lot about this stuff we don't know. That is what we are told about dark matter and dark energy. Now compare that to what we know about vacuum energy. Ubiquitous throughout the universe. There really is no such thing as vacuum space. There is either material or there is energy potential. In fact, even within an atom, yes, you have your protons, your neutrons, and your electrons, but the vast majority of even an atom is empty space. This stuff's inside there. It is a quasi-virtual particle, and yet its energy, sort of that connection between those worlds, and we can't really use it or study it in detail, and we don't know a whole lot about it. You know, there have been a couple of scientists in the last few years who have hypothesized that dark matter and dark energy is actually this vast, somewhat weak electric field, but which over large scales has tremendous influence over things that we think are normally dictated by gravity. Vacuum energy will be something to keep an eye on into the future because there is currently a dispute in mainstream science known as the vacuum catastrophe. And if you Google this, you will spend the next hour or so with your head in the clouds. Essentially, this vacuum energy, which is a very electrical concept, is something that is 100% accepted as existing by the mainstream. The problem, the catastrophe, is that between what we can observe and what the math says is possible, there is a gulf between them of 108 orders of magnitude. That's a 1 and then 108 zeros behind it. That's a really big number. That's the difference between what we can observe in the vacuum energy and what the math, things like the gravitational constant, Planck's work, says should exist. This is a big avenue for the future in terms of where this is all going to play out. I can't guarantee you that they're going to stop using terms like dark matter and dark energy, and I can't tell you that you're not going to have to get used to terms like that and terms like black holes when you talk about things like this, because we may never change the wording within the lexicon. But the concepts are clear. So many of the things described about dark matter and dark energy, and so many of the things described about vacuum energy are exactly the same thing. I actually have a video on YouTube called The Vacuum Catastrophe, easily Googleable. I think I just invented a word. You're welcome, Google. This is fairly standard stuff. Now, I know a lot of EU proponents would like to change the global electric circuit model, tweak things here and there. But still, even in the throes of what the mainstream grip has on it, this is what they say is actually happening on our planet. We have energy from the highest layers, and this includes not just electrons from the ionosphere and upper atmosphere, but solar and cosmic rays that are introduced to the atmosphere as well. These things come down in what is known as fair weather return currents, and they come down over orographic features as well. They juice up clouds, help create cloud condensation nuclei. A couple of brilliant papers from Brian Tinsley out of Texas have shown that these things will actually invigorate storms and actually build up the clouds to the point where they can actually enhance storms, like when we get hit with a CME impact or something like that. Let me see if I can go back there. There we go. Apologies. And so these currents, they are held in the ground and in the clouds, and during the storms, they actually go back up into the atmosphere and are part of the circuit when they come back down. Now, this sounds like a very electric universe type of thing, except this is all mainstream physics. The physics now says that when we get hit with a CME, it's going to compress our magnetic field. It's going to push the Van Allen belts towards the atmosphere. It's going to cause electron precipitation and a downward current that they measure in joules. These things deposit on top of the clouds, or they interact with the airflow over orographic features like mountains. They help create the cloud condensation nuclei, and they help juice up the storms. This is mainstream science. Boy, that's starting to inch very, very close to some of our electrical ideas of how the sun and cosmic rays can juice up storms. Well, you saw this for a moment. Now we're going to look at it again. That is lightning that has struck a golf course. Now that is very has a lot of dendrites there, but what we normally see is something like this. It tends to get dendritic and have a lot of fingers out near the end, but there are some clear cut and a very countable number of specific arms in these things. This is what you normally see. So you can see it gets really dendritic out near the fingers, but from the torso, from the core of where that lightning bolt struck, there's only a few lines out. Now take that in mind, a lightning bolt, an arc discharge, breaking out and then breaking out even more. That's in outer space, and it is claimed that that is the result of water, but one must ask, where are the actual lakes or anything else like that? And it actually looks like the water flow is going the wrong direction, doesn't it? People have heard about Martian spiders. They're not just on Mars. We took a close look at the images of Ceres and even at Pluto, and you can see these things as well. At no point is electricity given as an explanation for how these things come about. Well, how about one most EU folks are familiar with? Now, most of you know what this is, right? This is on Mars. Can we all say the name? Exactly. Now, there is the mainstream explanation for this, but I want you to notice how in the center there is a bulb, and then there is the bar that comes through it, and then the bar breaks out again at the end. So you have the dendritic fingers at the edge, you have the bar in the center, but at the center of the bar, there's that node. Well, this is what Billy Yelverton did in our electricity and plasma lab, using plasma currents going into the ground. Essentially, the same thing that you've been hearing from some of the big names in this group for a while, that it's electricity that's changing the geology, that it's electric terraforming, if you will, and that it's not all just about wind and rain and earthquakes. This is just a little something I added in there for fun. This is what it actually looks like in the middle of one of his experiments when he turns it on. What we had there, I don't know if you can see, but you have the circles of sand underneath the electrodes, and there are those two lines that come in between, one at the top and one at the bottom of the circles, kind of connecting them. That is the line showing where all of the sand was originally. We had literally just a bar of sand, and we took this image 0.6 seconds after we turned on the juice. The center had been completely evacuated and redeposited elsewhere. This is something you can see clearly. There is no interpretation of the math or the physics. You watch it happen, and you make a conclusion from it. Very, very elegantly simple. But anyway, I want to come back to here for just a minute, because there's more than just the reproducibility. Because even if we can reproduce that in the lab, what's to stop someone from saying, okay, you've merely showed another way to do it. We still think that this other way could work. Sort of that option A, B, C, D that I loved Michael Steinbacher for always presenting, always questioned himself. But there's something else about this image that just does not look right. And it really gets rid of some of those non-electrical explanations. Now, if you can't pick it out, let me help you. I've drawn a white line down the center. Now, take a look over on the left, north and south of the dendrites. Very nice, pristine land. Only a few craters. And then you look over to the right side. Is it more likely that asteroids just favored one side of this valley? Favored one side of this canyon? Just blasted the bejesus out of one side and almost completely ignored the other? Well, something else interesting happens in our lab when we're having these plasma flows. To create something like this, you need the sustained plasma flow. But on one side, we saw a ton of electrical discharges. And if you're familiar with the work of Yelverton's lab, or you've seen a lot of these things, you know that an electrical discharge, a powerful lightning bolt, is really good at creating a crater. In fact, we have done this experiment tons of times, hundreds of times, when you have a single arc discharge, the only thing it's going to do is make a crater. Now, if you can sustain it for minutes, hours, something we haven't been able to do in our lab, maybe something else. But when you're talking about a powerful single lightning bolt, something that's over and done with that fast, it can do nothing but a crater. We haven't seen it do anything else, and we haven't found anybody on the internet seeing an actual arc discharge, the lightning bolt, do anything else. So either asteroids favored one half of this area and completely ignored the rest over what the mainstream says is millions and millions of years of asteroid prejudice. I'm going to write a book. Or the same electrical power that carved this feature was also throwing lightning bolts at one end of it. That seems much more likely, and in fact, we've reproduced that in the lab now 10 times. Very, very simple. You can see what one side of this looks like versus what the other side looks like. Let's talk about some other things that are elegantly simple and are good pathways forward for our community, for people who are just getting into this stuff and want something not too complex to wrap their head around, but which is completely electrical. Everybody in this room has heard of the placebo effect. It is this mundane thing that we're all aware of. It is the bane of drug developers worldwide. But what it really is the laws of chemistry and biology within your system not working. Your electromagnetic brain waves that you get from thinking something overwrite the rules of chemistry and biology that are supposed to be working within your body. Now, that may be an unfair characterization of it because it's your electromagnetic brain waves actually changing the conditions for the chemistry and the biology. But there is no chemical or biological explanation for these changes. It is just because you thought it. That's what the placebo effect is. That's your brain being more powerful than other rules of science within your body. This is also why positivity and negativity are as contagious as the plague, because these things don't just sit within inside your body, they can affect the world around you. The Global Consciousness Project has proven that many times, and I won't go into that now, but if you want to Google Global Consciousness Project, boy, is that a beacon for the electric universe going into the future. It's also why laughter works. Why some people, even if they're not great looking, they're not rich or celebrity, why they're just something about them. Person has a magnetic personality. People are drawn to them when they walk into the room. Is that magic? No. It's the electromagnetic forces that we have interacting with one another. And by the way, the Global Consciousness Project shows that people can affect electromagnetic machines tens of miles away if they're thinking the right way. What about electricity and our health? You know, if you've ever had a sports injury, maybe you had those electrodes put on whatever muscle you needed to regrow, and it would help you sort of get that muscle back into working. But that's pretty much where most of us and our information on electricity and our health or biology, that's where most of it stops. However, over the last 100 years, in papers that came out in Russia and other parts of the world, not in this part of the world necessarily, at least until recently, talking about those same electromagnetic forces from the sun or galactic cosmic rays, modulating stroke risk, heart attack risk, suicide risk, seizure risk, migraine risk. On the large scale, they can track crime rates, pregnancy rates, infant mortality, large-scale revolutions versus time of peace. There's over 50 papers that came out of Russia on this over the last century, and just in the last 3 years, we have seen them come out of scientists from here talking about heart attack and stroke risks. They have a long way to go to catch up, so to speak, but this stuff is real. And simply because the world hasn't really wrapped their head around it yet does not mean you have to wait until they do. because this information is out there. It's coming out all the time. In fact, just this morning, I found an article talking about how the electric fields produced by the wound healing process of diabetics is significantly lower than the electric field of the wound healing process created by an otherwise healthy individual. And there are a number of papers that have come out talking about how electric fields can actually help wound healing be better, and other things like that. You can treat depression. You can treat pain. There are people who do this with sound as well, which I actually think is a nice little tangent that the electric universe should pick up at some point soon. The sound interplay, especially if you know that, you know how a microphone works. Essentially, electricity and sound can literally just translate into one another and back and forth. These things are elegantly simple. During the time when the sun is not very active, but we get a solar flare anyway, that is the highest time of heart attack and other cardiac-associated risk on the planet. This is not something theoretical. It's not really up for debate with the large N number, the enormous amount of people in this study. It's just an elegantly simple fact. And it only points to one thing: these electrical connections, not just between the Earth and the sun, but between all the living things here as well. The weather, the earthquakes, everything down to all of the animals that use the magnetic field of Earth as a compass. You start to open your mind in this way and you realize, hey, wait a minute. This is the future of science. And look where this community has positioned itself for that future. You should all be very, very happy that you're here. Last thing I want to mention, I told you I would be coming back to forecasting natural disasters. Well, we're going to be using things on the sun to tell when the Earth gets active. That chart I showed you before had the peaks in magnetism and the reversals. Trust me, I know when the Earth is going to be calm. I know when the Earth is going to shake. But I don't have any idea from solar indices where that's going to happen, how big it's going to happen. However, there have been more than 20 papers published in the last 10 years about GPS, ionospheric signals, magnetic field fluctuations, and other EMF signals as pre-earthquake signals. Well, you want to know what's amazing? All of our phones have those devices built into them. Everybody knows our phones have GPS. You can't download an app without it asking you to turn on location services. But did you know, chances are your phone has a magnetometer in it? Chances are your phone has an EMF detector in it? Do you know that it is easy enough to write an app to command those programs to send you data just as other programs command the GPS thing to send them data? Well, we are in the process of creating just such a thing now, where we're going to be using what we see on the sun to figure out when the Earth is going to get active. And we're going to be using people's cell phones to figure out where that energy is going. Now, it's not just for earthquakes. Let's say there's nothing on the sun that says we should be having an earthquake right now, but we know that the sun has put some eruptions our way. And there's a big difference between the strength of the magnetic fields of the sun over long periods of time and the short-term events like solar flares and coronal mass ejections and the storms they produce here on Earth. Well, we're going to be able to detect where space weather energy is coming in no matter what. So if it's not an earthquake watch period, but we're in the middle of a solar storm, and we see things like the magnetometer fluctuations that many people in San Francisco noticed before the BART train system went down during a solar storm earlier this year. Do any of you guys know about the BART train system in San Francisco? During one of the more powerful solar storms earlier this year, there were perturbations in the L-shell magnetic field located in the Bay Area. And the BART transit system had a number of electrical shorts that damaged a lot of its components, and they're still actually trying to get that thing back up to 100%. Now, in this case, that was an electrical disruption, not an earthquake, but it comes from the same type of fluctuations in our planetary system that are caused by space weather in the first place. And so this is something that'll be coming out this winter, the Disaster Prediction app, and the goal is to predict the timing and eventually location of the earthquakes once we get enough coverage with the cell phones. Obviously on day one there aren't going to be enough cell phones out there feeding us the data, maybe 6 months or a year later. But it'll also be able to give warnings about when these solar storms are going to happen as well. You know, back in 2012, there was a solar storm that missed Earth, but it was unfathomably large. 2 years to the day later, in 2014, NASA comes out with an article and says, it's a good thing this one missed us. This was a power grid killer, and we're very, very lucky. However, had you been watching our daily reports, about 7 hours after that eruption occurred, you would have heard and known back then that we were very, very lucky to have had that one missed. There is this prevailing idea that if there is something terrible that's going to happen, you really can't tell the people. Because even if you're 100% sure it's going to happen, think about the chaos, the rioting, the looting, the violence that might take place from people panicking. And if you're not 100% sure, think about the risk you're taking to communicate an uncertain risk. If there is a big solar storm, the kind of thing that could send us all back to the Stone Age, I promise you won't hear about it on the news. You won't hear about it from NASA or NOAA until maybe a few years later, if we're all around to hear about it. But you can watch our morning news and know what's coming, or you could not watch our morning news and eventually just wait for that notification to come to your phone that something big is about to happen. And of course, none of this on the sun or what we do on Earth would be possible without these electric models. And these things aren't even that complex. You can see them, and then you can see something else happening, or you can see something and tell immediately what it is you're looking at. There need to be two pathways forward for the electric universe realm. One of them I mentioned already. 10 years from now, Eugene Bagashof's going to be worth 10 of me. It's difficult for me to understand everything he says right now, and I know this stuff very well. There needs to be the Eugene Bagashofs, the Wal Thornhills pushing this stuff forward, and then there needs to be this elegant simplicity for people who are just now getting into it, for the people who will end up driving the movement forward into the future. Seems fairly simple, and the path forward is clear. Eyes open, no fear. Be safe, everyone.